right, we're going to do Unit 1, Equations and Inequalities. This is the very first section. This, the title of this section is Number Groups and Operations. Let's get started. You have, in front of you, you have some notes, and it's got a bunch of boxes. The boxes are going to show up here slowly, and here we go. Your number system started out when you were young. I'm going to tell kind of like a number story about you. Every person grows up like this, okay? You start off, and you notice, and your parents start touching things, and they'll start counting things. They'll say, you'll have some toys on the floor, and maybe they're picking them up, and they'll start saying 1, 2, 3, 4. That's the counting, or some mathematicians call them the natural numbers. So you're going to put the word counting numbers in this middle one, just right. Yours is it's red. Yep, right there. Counting numbers. And those start with 1. They start with 1, 2, 3, 4, and so on. And eventually you get the idea, because you'll ask your parents, when do they stop, Mom or Dad? And they'll eventually have to tell you they don't. They keep going forever, okay? So that's why I did the ... at the end. It's going to keep going forever. Those are your counting numbers. Eventually, you grow a little older, and something new comes in. Sometimes it's because somebody takes everything away from you, but you realize that you have nothing. And so your number world expanded only by one number. You had the numbers 1, 2, and 3, and so on. But now it expands to the number 0. I like to think, these are called the whole numbers, and I like to remember the whole numbers. And it's not the same word, but it has a hole in it. And the number 0 has a hole in it. H-O-L-E instead of W-H-O-L-E. But that is how I remember that the whole numbers start with 0. And they keep going. Notice that your box for the whole numbers includes the counting plus more. Okay? So far, so good? All right.
Which in the history of math, that was an
amazing
huge concept.
Idea. Yes, it was.
It took a while for them to
even get a number to represent nothing.
Yeah, and they actually used to represent it with the little bracket parentheses.
Because it didn't close. It didn't close. And I know that I've understood that the Mayan civilizations in South America had, when somehow they know it, I don't know, but that they had the concept of 0 before other civilizations did.
Yes, so that's how they believe that Egyptians were able to actually build the pyramids because
they got the concept of 0.
They had pi.
Yeah. Well, and they also had Pythagorean theorem and such. They had lots of math stuff. It's amazing stuff. And in the time of even Abraham, they would have had enough of that information because they were there when he was there. All right, I think I'm going to pause something real quick here. I'm looking at our number. You had 1 to infinity, then we started out with 0 to infinity, and now we're going to go both directions. The integers include numbers that not only go forward from 0, but now, and go this way, they now go backwards. -1, -2, and so forth. So your integers include the whole numbers, 0, and now they include the numbers going the other direction. So now your numbers are infinite in both directions. Those are the integers. We still don't have decimals. We still don't have fractions. We still have, in my opinion, the pretty numbers, okay? The pretty numbers.
So 2 1/3 isn't a pretty number?
In some people's opinion, it's not as pretty and easy to work with as the integers, okay? All right. Let's move on to the next level. We're going to expand it even bigger. This is the one that you actually learn about rational numbers before you learn about integers in your life. When you're in about 3rd or 5th, some even learn a little bit of fractions in kindergarten. We get to the rational numbers. These are your fractions, okay? If you think about this, you've expanded the number system an infinite number of times. So now, instead of you just having 0 to 1, you've got an infinite number of numbers between 0 and 1 now. You have the fractions. You have 1/2. You have 1/4. And actually the other way around.
Is it an infinite number though?
There are an infinite number of numbers between 0 and 1. So you have now an infinity between here.
So you mean 1 and 1?
And between 0 and 1, you can have 101. So you can have 0.01, 0.001, 0.00001, 0.012. So this is not only fractions, but it's now the decimals that represent those fractions. So we have an infinite number of numbers between 0 and 1. We have an infinite number of numbers between 1 and 2. And so we have an infinite number of numbers between every single number. We have expanded our number system. Huge. These are called irrational numbers. Be careful. These are only numbers that can be written as fractions. That's why we have this word rational. If you notice, there's a word right there. The root is called ratio, and ratios are fractions. So now we have expanded our numbers more than just infinity, because it's infinity times every number there was. Okay? And it goes backwards also. Your negatives are also there. But we have the fractions in between them. All right? Our number system's not done. Because there's still these, like, I don't know, the left outs are the ones that are, like, not included in the fractions. There's some things that can't be written as fractions. And Miss Jessica mentioned it a little bit ago. There's pi. Pi cannot be written as a fraction, at least with the knowledge that we have in our minds at this time.
Where does the rationals go?
The rationals, your irrationals are this box down here. Okay, your irrationals are down here.
And you're 200% positive.
I am only 100.
Okay.
So there's no way for me to be any more than 100% positive.
Is there?
All right, so we have pi is one of the irrationals, okay? We have any of the square roots that are not perfect. For example, square root of 3 will go on forever and ever and ever and never become a fraction. The square root of 4 does not count because the square root of 4 is a nice, beautiful 2. So that one will not go in there. So don't put the square root of 4. Square root of 3, square root of 6, square root of 10 will be irrational. Those are the ones that don't fit. They're the leftovers. They're the leftovers. Natalie did wise. She made her own. Just get rid of the one that I gave you. All right, all of these are what we call real numbers. And some of my students are going, what? As opposed to the fake ones? These are all called real numbers. These are all the real numbers. And these are the numbers that you probably have seen sometime in your life before now.
And where does reals go?
Reals goes all the way around everything that you have so far. Except for there's a little bitty leftover at the bottom that we're going to talk about very, very briefly today. All right? So everything is the reals. You'd think that the ones that are left over are going to be called the fake, but they're not. And we're going to talk about these second semester. These are called the imaginaries.
My favorite kind of numbers.
I know. The imaginaries. We're going to talk about those very briefly right now. And the briefly that it is that they are called the imaginaries, and that's it. No more. Questions so far? All right. You have the very, section 1.1 on your assignments, you have a problem that looks like this one. It's on the very last page of that assignment. This is where we do some of the assignment in class. Brett was saying some of our times we do some of the assignment in class. Keep going, Isaac will get there. Right there. We're going to do the top of that page. See it? We're going to do this together so that you can, because if I just tell you all that but I don't help you understand how this affects what you have to do, I think that I would have failed. So what we're going to do is you have, similar to the drawing that I have, except this one is got the right boxes. And we're going to take every one of these numbers and put them in here. Negative 19, is negative 19 accounting? In this case, they call them naturals. Is it a whole, an integer, a rational, or an irrational? Go ahead, Natalie.
Integer?
I heard integer. Do we agree?
Yes.
Yes, it's one of those negatives. And it's a negative that can be written as a fraction, so we're going to put negative 19 in there.
That's in whole.
Oh, thank you.
Messed up.
I know, that happens. I'm human. Thank you for helping me.
At least you admit it.
Yes, I try. All right, next we're going to go over there to the 1.2 with the line over. What's that line, remember? What does that mean?
Totally irrational.
Never ending?
It means it's never ending. Is it irrational or rational?
Irrational.
Can it be written as a fraction?
No.
It can. If it repeats, it can be written at, and this is why we're going over this. If it repeats, it can be written as a fraction. If it doesn't repeat, like this one, won't repeat, because they have that ... it's going to keep going and won't repeat, then it can't be written as a fraction. This one can, so where does it go? It's irrationals, yes. So we're going to go 1.2 with a line. We're going to scoot over to 0. Where does 0 go?
Hole.
It is a hole, and it's got a hole in it. That's how I remember, yes. Okay. We're just keep scooting over. We're going to move to 3. Where does 3 go?
That's an irrational number.
That one is the one that you would have started with when you were young, and that would have been
Natural.
the naturals, or the counting. That we there's 2 different words, different mathematicians use it. It's the natural, it's 3. Okay. Square root of 10.
Irrational.
That's irrational.
That one is irrational. That is true. There's cute. You have to look up. There's jokes about irrational numbers. I'm screaming irrational. Anyway, square root of 81.
That's rational because it's
How?
9.
Because it's 9. That's correct. It is
That's
rational.
rational.
Wait a second. It's 9.
No, so it's a count.
So it's
it's
not just
extra.
rational. It's extra. I mean,
We don't have extra whatever
But
you're
then
going
that
to
could
say.
go down to
it can go down. So you see, rationals. Yeah. So it's not. It's rational, yes, and it is an integer, yes, and it is a whole, yes,
And it is also
but it's but you need to go down to its lowest. So it's
It's a-
actually
a
natural
natural.
since it's 9.
yeah.
Okay. Anything the rational anything that's down here goes up. So
So should we write 9 or 81?
square 81.
Which
All right.
Mine? That's mine.
Do we have some blings?
Tell them what it is.
All right, we're scooting over. 3.456. It doesn't repeat.
It's rational.
It doesn't go on forever.
It's got to be rational.
If
I
it
heard-
doesn't go on for it
Rational.
does not.
It doesn't. Notice there's not a dot dot dot, so it does not go on forever.
So it's
It's
rational.
So it is rational.
I
Yes.
said rational. I got it right.
All right. 3.456.
You're so creative with your numbers.
Negative 6/11.
Integer.
I heard an integer.
Why is it in
Rational.
integer?
Why do you think it's rational?
Because it's a fraction.
Because it's a fraction. Yes. These
Why did you
integers,
say
remember,
integer?
I don't know if you remember, I called them the pretty ones.
Yes.
And some people don't like fractions, and not that I like fractions, but I call those the pretty ones because
Hold
people
up.
don't like them
I
as
want to
much.
hear your thought process. Why would you think that was in
Because of the negative of it.
Because
No,
yeah,
I couldn't remember which one was fractions. I thought
yes,
we'd introduced fractions and integers, but I.
yes, it's the one with ratio makes it
Yeah, yeah, yeah,
I
yeah.
have a
fractions. Okay, yes.
Is that 2 i's plus 3?
This actually good question. That's a pi. It's whatever font
Oh,
they
I got
used
you.
did not
Good
fit
word.
well, and it might look better on your. Oh no, it doesn't. It looks like an I doesn't. All right, so I don't have enough room to write, so I'm gonna have to reduce my little numbers in
And
here.
then this next one is definitely rational.
This was
That's
Goes on forever.
negative
Irrational.
one's negative
That's got to be irrational.
6/11. All right. This one, it says it goes on forever. It doesn't give you an idea that it repeats because there's no little lines on it. So I heard that it was what?
Irrational.
Irrational. Negative 1.4829. Pi plus 3.
Irrational.
Because
Because anytime it goes over.
anything with pi. That's right.
Anything with pi is always irrational.
You're always irrational. You might have said that. I just wasn't sure. That last one, negative 44. Is it natural?
Integer.
Mm-hmm.
It's an integer. Why?
Because it's negative.
So what could I have made it? How could I have made it natural or whole?
Negative 11.
Take the negative.
So negative 44 is rational.
Negative 44 is rational. That's a good. Yeah, actually, you need to. We're gonna negative 44.
I'm
Listen, if it is an integer, it's rational.
Okay.
If it's natural, it's.
All of the above.
That's not true.
Man.
No, if
whole
it is
thought
the other way
process is
around.
just thrown off.
If it,
If it's
yeah, if it's integer, it's rational, right? Yeah. If it's natural, is it whole?
Mm.
Yes.
Yeah.
Yes. If it's natural, it's whole.
Mm-hmm.
If it's whole, and it's also all the way up. But if it's rational, it's not necessarily, it's not below. Okay? So when you do yours down here, on number 24, it says list all the characteristics. So square root of 10, you already did. Square root of 10,
It
you
says
know square root of
classification.
10 goes under irrational. Is there anything else you can write with square root of 10?
Everything.
Real. So it would be irrational and real.
Real.
Where's real?
Real is all of them.
Oh, we gotta write.
So down below, you'll have to write real on everything. Yes.
Can I do this?
Okay.
So I'm just gonna go for real.
You got to talk to your mom about it. You're going to put a ditto at the end, huh?
There we go.
All right. So if I listed negative 67, what is this one? Integer,
Whole, natural. Oh, no, yeah, just integer and rational.
integer, rational, real. Okay. All right. So wherever it is, it can go up.
So, 81, could that be also
The square root of 81 or 81?
Square root of 81.
Actually, in this case, it wouldn't matter. Square root of 81, we
Would that
wrote
be
it
considered irrational
as
because-
natural, so it can be natural, whole, integer, rational, real.
Okay.
Okay? All right.
This is like not making sense right now. I'm sorry.
Okay, ask me some questions so that I can help you.
How the heck do you do, like everything?
Wait,
I know. I
would it
understand
be-
everything with pi is irrational.
Correct.
Everything with a minus, I don't get that. And then like fractions, I'm so like mixed up. 'Cause
So
you
if it's
keep
got a
jumping from,
negative,
like, this
if
one
it's
to
got a
this one.
negative, you do know where it goes. Do you know that it's an integer?
Okay.
Okay. So and because I think let me see your pencil.
81 wouldn't be an integer because it doesn't go down.
Order of operations. I am on the next page, I think, of your. Maybe I don't. On your notes. What is on the next page of your notes after that one? Let me just make sure I know. Yes. All right. Order of operations. I've got just an overview of this. You have seen this before, I think. Your order of operations, if I give you a bunch of numbers to add and subtract and multiply, divide, and with some exponents, there is a special order that you must do it in. Many things in math are just the way it is. 2 plus 2 is 4. I didn't make it up. Nobody in the world made it up. When God created the universe, he said that these two things, and I combine it with these two things, make 4. The order of operations is not one of those kind of things. It's not just the way it is. It is so when everybody on the planet does their math, we all will get the same answer. Technically, someone in another country could do their math in a different order than us. And when they give a long line of numbers up, and they did their math, they would get a different answer than us. Could you imagine how that would be, like, not a good way to do things? All right. So,
you're gonna trip.
I'm sorry.
You're fine.
I might even step on it. I don't want to hurt it.
No.
So they've come up with a standard to add all these numbers up. And these standards are also quite logical. So not all of them were just dictated by some person who just sat around in a room and said, you know what, I really want to make their life really awful. Let's make parentheses first. No, these actually have some logical reason why they would pick them, okay? So if you're going to do a bunch of math together, you will put everything that's in the parentheses you're going to do first. The next thing after that, you're going to do the exponents after that. After that, you're going to you're going to multiply and divide, but you're not going to always do multiplication before division. You're going to do them from left to right. And I have already put these down, and there's a sheet for you to fill in the left to right, and that's the reason I had you write that in, because it's really important. If division is to the on the left first, you'll do it first. If multiplication is on the left, you'll do it first. So you need to look to see which is the most left. So there's a little fill-in-the-blank part for you, Isaac, right there. Last but not least, you'll do your addition and subtraction. Okay? You'll also do that from left to right. So we will make sure that you do these from left to right. Addition's not always before subtraction. There is a cute little saying, and there's not just one, I'm sure there's lots and lots and lots. And it's with this PEMDAS.
Please
Excuse my dear Aunt Sally, and you can fill in the blank. Please excuse my dear Aunt Sally. I'll just put it all up there for you, please. And if you don't even want to write it out, don't. It's up to you. If you already know it, please excuse my dear Aunt Sally. I think there's some other ones. Be careful if you want to look them up, because there might be some ones that said mean things. We're going to do some problems together. We're going to do numbers 1, 2, 4, 7, and 9 together. If you'll do me a favor, if you'll circle those, because I'm going to get out of this part of the program, and I need to help remember we're doing 1, 2, 4, 7, and 9. Tell me when you're ready you've written those down for me. You've at least maybe circled them in we're going to go to section 1.1, and we're going to do numbers 1, 2, 4, 7, and 9. We're going to do some of your homework together. All right. And those of you who are used to doing this with me, number 1, it said we're going to do in parentheses first, then exponents, and then multiply, divide, and add and subtract. The thing that's in parentheses right there isn't an operation. It's just indicating that there's a negative. So there really isn't any reason to do that. first, what do we do first instead? The exponents. What is 2 to the second power?
4.
Now, I'm going to make some very, very strong suggestions. I'm going to suggest, for one thing, for me, when you bring this to me and I look at it, there will be work to be shown. Because your calculators, you type that in, it'll do it for you. But you need to show me that you do it in your head, okay? Not that you don't do it in your head, that you do it here. So you're going to bring down that -4. If you don't want to put a parentheses, I don't care. It's fine. But the thing that you do is, the next one is the times 4. So you'll bring that down, and I'm going to have you keep the 6. You need to have a systematic way of doing this. So you writing this down, Isaac? Well, here we go. So we got -4
I'm trying to see if this will work.
times 4 plus 6. I'm sure.
Error.
Wait, make sure when you
That's what I
do
got.
it, please, that you do it right underneath it. Bring each number
So
right
go to the go-to.
underneath it down so I can see what you're doing.
You know what? This doesn't actually charge it. This and that thing is just for you to do. So you have a decimal and not a times.
What?
Oh, I did.
So you could use your go-to
Still error.
because you used a subtract instead of that negative down there.
Okay.
All right. So you can use it to check your answer.
Yeah, just show
Okay.
your work.
All right. All right. So you're gonna have to show your work, but you can use it to check your answer. Will be fine. So what do I do next on this one? Do I do the multiplication or the addition? Multiplication. And so again, this is review. You might not have done this for a while over the summer. So -4 times 4 is 16 plus 6. Now there's only one thing to do. What is 16 plus 6?
Isn't it negative? It's negative.
It is, thank you. What is -16 plus 6?
Negative 10.
-10. And that's what Isaac got on his calculator.
I already had it on a piece of paper. I just need this.
Good. What number do we do next?
2.
Number 2. So even though you're supposed to do this from left to right, as long as you keep that positive with the 36, you could do these first, because addition is commutative, and so you can do those in multiple orders. I like to subtract.
4 from 5 and
Yeah, that would work also. You could have done that, which would have been 1, right?
Mm-hmm.
And then add that 1 to the 36 to make it the 37. I would be willing to accept that, yes. If you wanted to write that out to do this and make this be 32 plus 5 makes also 37, it works. Okay? What number's next? This. The fraction line right there is almost like a parentheses. So you knew everything on top of that fraction first. Okay? It's like a hidden parentheses. So what is 8 minus 3? 5 over 5 minus 6. Show our work. Now what do I do first in this sense?
Simplify the fraction.
Simplify that fraction. The 5 over 5 becomes 1. And 1 minus 6 is,
-5.
careful, is -5. And we do check our answers with each other. It's not a secret. We're not in competition. We're here to help. The problem comes when one person does all the work and then just tells the answer to the other one. That's the problem. But if you guys are both doing your work and you come to it and you're collaborating, that is what we're do together. And that's what we do in class together, as we collaborate.
I'm just curious. I know we weren't going to go over this one, but I don't know what order to do it in.
Okay, in a moment, I'll come back to it. All right, what's the next one we're going to do together?
7.
7. All right, here we go with number 7. I'm waiting for my screen to catch up here. Number 7, we are going to plug numbers in, okay? Whenever we see a letter C, we're going to plug in
Got it.
a -3.
Done.
We're going to plug in an A, we're going to plug in a -6, and a B, we're going to plug in a 3. Be very careful with those negatives that we have extra negatives sometimes. So I'm going to rewrite this. This C becomes
Hold up. Did I get the
-3.
answer right?
In just a second. We'll check it in a minute. You'll come up. Plus A. A is -6. I don't know. I like just writing -6 there, but you can do a plus negative. Minus B, and B is 3. Minus 6 plus C squared. Be very careful. It's the whole part of that -3 squared. I put it in parentheses so that we can see it.
Oh, hold up.
I will hold up for sure.
No, I'm not talking to
Okay,
you. Sorry,
good.
I was talking.
I am going to do the exponent first. That's right here. That's 9, and that's positive. Plus that -6 minus, or that -3. I'm going to change that to be a -6 and a -3. Okay, good. All right. We got this right here. I'm going to work from left to right because there's no multiplication. I've got -9 minus 3 minus 6 plus 9. Oh, I'm not going to go in order. Is there something you guys can see that would really be cool to just get rid of?
Yes.
What?
The 2 9s.
The 2 9s. I'm just going to go. All right, get rid of them.
I love it.
I
Love
cannot
it.
believe I got that right. God.
And then we have our negative 3 and negative 6 become what?
Confused.
I negative 9.
9. Who said I'm confused?
Me.
Okay,
I'm
where?
sorry. I left something out when
Okay.
I was trying to.
So we're going to do it together. Some of
Too
you are
late.
ahead,
Already
and that's
did it.
fine, but make sure that you understand and get it right. 4 minus the y is negative 2, and the negative, I'm going to actually put the negative there. We have a plus an x, which is 5, minus 1, minus z, and z is negative 6. Do not forget the negative. It's catching up.
Negative equals a positive.
That's correct.
Yeah.
Then all over 4. I actually am going to correct my negatives. That's what I'm going to do first. So I'm going to correct these first. So I'm going to go 4 plus 2 plus 5 minus 1 plus 6 all over 4. Remember that big long fraction line really means parentheses. You're going to do everything on top first. Okay? So I just want to move left to right, unless there's something that someone else wants me to do in a different order.
No, I got 4.
I'm going to make that be 6 plus 5
Yeah, I messed up. You read these.
minus 1 plus 6 all over 4.
He goes, yeah.
I got an 11 minus 1 plus 6 all over 4. I'm going a lot of steps so you know where I got it all. I've got a 10 plus 6 all over 4. And I'm running out of room, and I have the wonderful ability to just reduce it.
Yeah, you got it right, Britt.
Am I,
did it.
you got it?
Yeah, I got it right.
I have 16 over 4, which becomes what?
4 over 1.
4 over 1. And you can leave it 4 over 1, which is fine.
I
Or
put
you
a
can make it
4.
just plain old
Yeah,
4.
I just
Yeah.
put a 4.
I'm an efficiency, I don't know about expert, but I want to write as least amount as possible, so I write only 4. But it would be correct to do 4 over 1. Okay. Questions? Was there another one? I think 9 was the last one I was going to do when you guys circled them, correct? Okay. Next, we need to learn how to simplify expressions. Let's get started. All right, first we need to know what it even means to simplify an expression. It means that we're going to combine as much as we can. But you need to realize that we'll probably be left with an expression. When you're simplifying, you can only combine like terms, and these are terms that have the same combination of letters and exponents. Let's do some of the examples so that you can figure out what I mean. All right, we're going to do the distributive property on this one. This is a review also. We're going to take that 6 and we're going to multiply it into both of them. We're going to do that 6 times negative 6, which is negative 36. Don't forget the m. We're also going to do this 6 and the 7 together, which will be 42, but don't forget your subtraction. Are you with me so far? I don't want to go too fast.
You've already done.
Good. If you're done, then I'm going too slow. All right, so what can I put together now?
The 42 and the 7?
Yes, the negative 42 and the 7. What is negative 42 minus 7?
Negative 49?
23.
No, I got 45.
Isn't it 49?
49.
I got
Nine.
negative
What?
49.
I was subtracting. I'm
I
sorry.
got negative 49.
I don't know why I was doing that. 49.
How'd you get that?
Okay, because they're both negatives. And so we're at negative 42 and we're getting more negative to 49. Okay?
Yeah.
Can I put this together? Am I finished?
Yes.
Yes, I'm finished, and no, I cannot put them together. You're right. Okay. So I guess no matter how you would answer that question, you would have got it right.
You know what I meant.
Yeah. Of course you meant that you were finished. I knew that. All right.
Do we bring our assignments to get checked in?
Yes, you do each week.
So
Check them.
2 weeks from now, you'll just check all of our
I'll
assignments.
check to make sure you did everything. Yes.
Boom. Look at that.
All right.
But this is all of our homework for semester 1.
No, for this week.
Sweet.
Yes.
Y'all wish.
We got 3 lessons equipped.
The number system. We talked about your number system with your integers and reals and irrationals. You did some order of operations. You simplified some expressions. That was our very first lesson.